Okay, today we're going to be looking at section 4.4, other common functions. In this section, we're going to graph piecewise functions, identify absolute value functions, identify and evaluate piecewise functions. We're going to identify functions in the form a divided by x to the n, identify functions of the form a to the x raised to the 1n power, 1 divided by n power, that is. Identify functions of the form ax to the n power. We're going to identify graphs of common functions and identify greatest integer functions. Now, I've looked through this information. I think this is probably one of the most helpful learn sections as far as giving you a visual of what you're looking at and getting you prepared for what you're going to do in the section. So the first one we look at is common power function. So that's a to the n power. It gives you an example. A is just some number, a constant, and then you have your variable x, and then n is the power. So a power function is just showing you the general form, and then these are some examples. So this first one is a linear function. It is a first degree is odd. The next one is an x cubed and then an x fifth. Now what you'll notice is that all of these odd functions, when they're positive, so there's no negative in front of them, the graph is going up as we trace it from left to right. The left part is on the down and the right part is in the upper corner, and that's in all cases. So that will be the case when they're positive. Now if this was negative, it would just flip. It would be the opposite. But these are very important properties. And then we have some even exponents. So notice we have x squared, x to the fourth, x to the sixth. They all look very similar. Okay, they're all U-shaped going up. So that's when they're positive. If they were negative, they would just flip down. And you'll see some of those properties, and it explains that down here. As this a value changes, it will compress the graph, stretch the graph. And while I'm here, let me also point out in our Blackboard, our content, I believe in Module 2, parent functions. I'm going to go to the parent functions plus. Many of these graphs are here with some additional information regarding domain and range and some properties. However, if you scroll all the way down toward the bottom, this is the last page. This is also telling you about the transformations, but it gives a little bit more. So the A right here in front says a vertical stretch up or down, or it's also called a vertical dilation. Larger stretches it out, makes it look skinny, and the smaller makes it look wide. It widens it out. So that's also there in Blackboard in our content. Then you have some examples where you got to kind of pick out which graph matches. So if you go back to those even properties, odd properties, that will help. So even, they're both going the same direction. Also, I should mention, they will ask you to find some ordered pairs that are on the graph. You can pick any x value, plug it in, and then solve, and you'll get a y value. One of the easier ones to do is just plug in 1. So these are some forms of a to the negative n. So that means n is on the bottom. So that's a divided by x to the n. So it's like 1 over x. Like here, x to the negative 1 power is 1 over x. Again, it's positive, so you have something in the positive right quadrant and then in the negative quadrant. Left to right, going left to right. If it was negative, it would be the opposite. But all the odd ones have the similar shape. And then all the even ones, okay, both in the upper quadrant when they're positive. And when I say positive, that's this term here. And then you have some descriptions with domain and range down here that they all match up. Here's an example provided by the Hawks. Now we have a to the x, ax to the 1 over n power. So these are radical forms, radical functions, square root functions. Whatever the bottom number is, that's the root that you'll be dealing with. So if it's 1 over 1, it's just regular x. 1 over 3, that 3 is the cube root. Okay, so the bottom number is the root. And then 1 over 5, that's the fifth root. And again, notice they're all going left to right. Anytime you're dealing with odd, it's increasing left to right. Then you have even roots. So with even, you can't have negatives under square root, so it only shows on the positive side. 1/2 is just a regular square root. 1/4 is a fourth root, and 1/6 is a sixth root. And again, all of those look similar. We have the absolute value function, which only makes positive, so everything is going to be above the x-axis. And then again, they talk about how changing A will change the visual of the graph. Have some examples. So here's one of the things you will notice. This one is now negative. So all the negative is doing is flipping everything across the y-axis. Okay, so it was positive, and then when y is negative, it goes below the x-axis. Then we have the greatest integer function. So this is one that's been around for a while, but I've never really used it. It's usually something that we kind of skip over. I haven't actually seen any applications of it because we never really use it. But we're going to actually see it at least one time in this section. So the greatest integer function, which they also call a step function, looks like it just jumps. So it's picking the greatest integer in a lineup. So of these numbers, the biggest whole number is, so this is 4. So 4.1, the whole number is 4. Okay, we can't, that's the biggest whole number out of that range. So from 4.1 to 4.9999999, the whole number is 4. So it all just stays on 4. And then when you get to 5, it jumps. And it does that for every line. And we'll also look at some of these properties, which I'll explain as we see it in Hawks whenever we start working these problems. And then we have a piecewise function description of what it is to be well defined. And then we have one last example that you get to see. So this is a piecewise function graph. And I don't think it's necessary that you have to graph these, but I will show you how to graph these with a calculator. I think it's really neat. And you can just watch the video over and over and follow the steps. You can also find steps on YouTube. But with that, we're going to go ahead and stop here and jump into Hawks and start doing some examples.